minit, dalam 2 minit untuk kamu tulis maklumat depan ni lah. Tulis maklumat dekat bahagian depan ni. So after lab, you have to submit the lab module lah. Okay. So kita tulis siap-siap maklumat depan ni, student name, metric number, program semua tu kat bahagian depan. Okay, dah tulis kan semua maklumat? Okay. Okay, so next kita akan masuk ke lab objektif lah. Okay, the first one, this lab to make sure that the students understand the operation of IDMT or inverse time overcurrent relay. So IDMT is also one type of inverse time overcurrent relay. Apa yang you faham pasal inverse time ataupun IDMT relay ni? Yang you dah belajar sebelum ni lah. Siapa boleh jawab? What is the theory of IDMT overcurrent relay? How it operate lah. Ada siapa? Boleh jawab? Okay ke? So IDMT or inverse time overcurrent relay ni dia operate on based on the fault current lah. The higher the fault current, the faster will be the operation time. Betul tak? Inverse time relay. The higher the fault current, the faster the operation time. Okay. So that's the first objective, to make sure that the student understand the operation of IDMT overcurrent relay. Second objective, to make sure that the students can design the settings of an IDMT overcurrent relay for a transmission line and prove the settings using simulation. For this lab, you have to decide the relay setting lah. What is the setting for IDMT or inverse time relay? Jadi dua setting kan. The first one is the plug setting, right? The second is the time multiplier setting. Okay, kalau awak dah baca, awak dah study tu awak akan ingat lah. So the first setting is the plug setting. Second is the time multiplier setting. So based on the setting, you will prove using the simulation lah. And then we go to the introduction. As an engineer, you are required to determine the IDMT overcurrent relay settings for a newly installed transmission line as shown in figure 1. So the relay function to protect the transmission line from fault occurrence. The parameters for the line are shown in table 1, while table 2 shows the setting range for IDMT overcurrent relay. So this is the transmission line. So let's say this transmission line is just installed in our power system lah. So you as an engineer, you are required to determine the setting for this IDMT overcurrent relay. So IDMT overcurrent relay, it will be used to protect this line from the fault current occurrence at this line. So this is just a single line here. So you are required to determine the setting for this IDMT overcurrent relay. So and then you have to validate or simulate that the setting that you set are correct lah. So based on this transmission line parameters in table 1, you have to determine the plug setting and also the time multiplier setting of the relay. And then using these two tables lah, you have to decide the plug setting and also the time multiplier setting of the relay. The second table ni is actually the setting range of the plug setting and also time multiplier setting. So you have to choose a setting for plug setting and also a setting for time multiplier setting based on their setting range inside this table lah. Okay. And then to prove the settings, the students have to change the fault resistance value to get different fault current. So in the simulation, because we want to vary the fault current, so we have to vary the fault resistance value lah. Meaning when we change the fault resistance value, the fault current also will change. Because we want to test our relay, it must be set by different fault resistance value lah. And then based on the fault current values from simulation, the students have to calculate relay operation time based on the plug setting and time multiplier setting. So based on the setting that you have decided, the setting, the PS and also the TMS, and then you have to calculate the relay operation time from the fault current values that you get from the simulation lah. And then finally, the students have to compare the values of calculated relay operation time with the operation time from simulation. So you have to compare the operation time between the calculation and also with the operation time from simulation. So the first one, the lab procedures, based on the transmission line parameters in table 1. So from this table 1, okay, refer to back to this table 1, determine the suitability ratio. So you have learned in the class how to determine the suitability ratio, like so first what you have to do, you have to calculate the, ingat lagi tak formula yang kamu kena calculate dulu untuk tentukan suitability ratio? Siapa boleh ingat? Siapa boleh bagi tahu lah? The first thing that you have to determine lah before you can set the suitability ratio. Ada siapa ingat? Tak ingat lah. So first you have to calculate the full load current, right? Full load current. So from this table, you have to calculate the primary full load current. So after you get the primary full load current, let's say your primary full load current is katakan kamu calculate dapat primary full load current kamu katakan 652. Okay, 652. So macam mana you nak tentukan CT ratio you? So you ambil yang lebih tinggi tapi yang paling dekat lah. Berapa? You akan ambil berapa? 652. 700. Okay, 700 slash 1M ataupun 700 slash 1M. Kat belakang ni terpulang lah. Kamu nak letak 1M boleh, or you can choose 5M. Depend on you lah. So your simulation will based on the setting that you have set lah. Okay. So dekat nombor 1 ni, you have to calculate I full load primary value lah. Okay, primary value, and then you decide the CT ratio lah. Okay. So soalan 1 ni dia minta awak calculate the primary full load current, and then from the primary full load current you decide the CT ratio lah. Okay, then propose the plug setting and also the time multiplier settings for the relay using the information in table 2. So in table 2, it already gives you the range for the plug setting and also the time multiplier setting. So you have to decide lah from this range, what is your plug setting, and what is the time multiplier setting. So for TMS, you can set any value from 0 to 1. instead of 0.05. So dah ada step kat sini 0 to 1 instead of 0.05. Kalau plug setting 50% to 200% instead of 25, meaning 50, 75, and then 100, 125, 150, 175, 200. So dia ada dia punya setting range, dia ada dia punya step lah. So you have to follow the step and also the range lah. And then the plug setting should be more than 100% of relay rating. So previously you have to you already decide the CP ratio. So based on the CP ratio, the plug setting must be 100%. Should be more than 100% of the relay rating, or more than 100% of CT secondary current lah. So this you kena decide lah what is your plug setting. You can take 1.2, 1.3, 1.4 or anything lah. And then show all your calculations in part 1 of answer sheet. So you tunjukkan dalam ni lah. Okay. Tunjuk dalam ni. Kat sini macam mana you calculate full load current, macam mana you tentukan CT ratio. And then macam mana what is your plug setting, what is your TMS setting, tunjuk dalam ni lah. Okay. And then put the relay setting parameters inside the relay interface. Double click the relay block to open the interface. So after you already set the CT ratio and also the plug setting and TMS setting, you have to set the relay lah. So to set the relay, you double click at this block, Idmt relay, double click here. So and then just put the value lah. Okay, put the value dalam ni lah. Okay. Masukkan based on your calculation lah. Okay. Based on calculation, masuk dalam tu. And then the next step, you have to test the validity of your proposed relay settings. To do this, you have to change the fault resistance value by changing the fault resistance. Okay. So nak change the fault current tu, you kena change the fault resistance value lah. From 0 to okay. By changing the fault resistance, the fault current also will change. So please choose any 3 fault resistance value from 0 to 100 ohm. So you have to choose lah any 3 value from 0 to 100 ohm. Kalau kita nak pilih lebih pun boleh, tapi dia akan jadi lagi lambat lah. Sebab tu saya setkan from 0 to 100 ohm lah. And fill the chosen fault resistance value inside the table part 2 of answer sheet. And then fill in the table here lah. The table here, what is your fault resistance value? So from simulation, you will get the RMS fault current. And then to change the fault resistance value, double click the fault block and change the parameter inside the dashboard as shown in figure 3. So dekat sini, to change the fault resistance value, you have to double click the fault block here. And then change the breaker resistance here. This is the breaker resistance to represent the fault resistance lah. So you have to change the value here for three different value of fault resistance. Okay. And then run simulation for each fault resistance value and wait until the simulation stops. So you have every run of simulation, you have to wait until the simulation stop lah. You cannot take the value during the simulation still running. You have to wait until the simulation stop and then you take the final result lah. Then take the fault current RMS value from simulation as shown in figure 4. Okay, this is after the simulation stop, you have to take the fault current, the RMS fault current value here, such as here 1401. Okay, so you have to run simulation for each fault resistance value and take the fault current value lah. Fill the fault current value for each fault resistance in part 2 of answer sheet. So masuk dalam table tadi tu, dia punya fault current punya value lah. And then based on your proposed PS and TMS, calculate the operation time for each fault current from simulation as in step 5. So after you get the fault current, you have to calculate the operation time for each fault resistance value based on using the plug setting and TMS setting that you have determined previously lah. And fill the calculated operation time in part 2 of answer sheet and show your calculation of relay operation time for all fault resistance value in part 3 of answer sheet. So in this table, based on the fault current value, you have to calculate the operation time of the relay using the plug setting and TMS setting that you have determined previously, and then show your calculation of operation time for different fault resistance value in this part 3 lah. Part 3, let's say this is 10 ohm, 20 ohm, this is 50 ohm. So you have to calculate the operation time for each for each fault resistance value lah. Okay. And then next you have to get the operation time from simulation. So next you have to compare between the calculated operation time with the operation time from the simulation. Okay. The fault has been set to occur at 0.1 second. So in the model, I have set the fault to occur at 0.1 second. Thus, the relay operation time is equal with the trip signal time subtracted with 0.1 second as in equation below. So after, when you get the trip signal time of the fault resistance, you have to minus this time with the fault insertion time, which is 0.1 second for each different fault resistance values lah. Okay. So figure 5 shows how to get the trip signal time. So this is the step how to get the trip signal time. First, you have to auto scale the results, and then you have to zoom the trip signal. The trip signal is the last results from the scope lah. And then you get the trip signal time. So this time you have to subtract with 0.1 second. Okay, faham Boleh Ada soalan tak? Okay tak? Clear tak? Siap dah?
Saya kalau tanya, kalau ada soalan lagi saya tanya balik.
Okay. And then calculate the percentage error of relay operation time for each fault resistance value using the equation below. Fill the calculated errors in part 2 of answer sheet. So you use this equation to calculate the error of the relay operation time. So the error equal is the operation time from simulation minus operation time from calculation. This is the value that you calculated using the fault current value. Divide by operation time from calculation and times with 100 lah. So you have to fill in the error inside this table lah. So the error. And then print screen the simulation results. This is the scope. So you have to print screen the results for each fault resistance value and put the results in part 4 of answer sheet. So you will have three scope ni. Sebab you ada 3 fault resistance value kan. And then the example of simulation is shown here. Ni adalah contoh scope yang kamu print screen masuk ke dalam part 4 tu. So make sure you already auto scale the result. Okay, make sure result ni sebelum kamu print screen ni kamu dah klik auto scale ni. Baru dia akan nampak result yang keseluruhan lah. And then finally answer the question part 5 of answer sheet. So last kali jawab soalan dalam part 5 je lah. Okay. So step semua saya dah bagi dah. So you just follow the step. Kalau ada apa masalah boleh tanya lah. Okay. Boleh kan? So itu sajalah untuk ni. So you kena try buat sekarang lah. And then kena submit dalam masa lab ni jugalah. Sebab awal lagi kan baru 10 setengah. So I just explain the step for you and then you have to simulate by your own lah. Kalau ada masalah boleh tanya saya. Okay? Boleh
Okay, sir.
Okay, boleh try dulu.
Alright.
follow the step.